probably turn my camera off and I'll just listen in.
Great.
And it's preparing. Done. Okay, we should be live. So over to you, Ian.
Excellent. Well, welcome to the e-NABLE and new member meetup. I'm just going to send out the member meeting to a couple folks that were requesting it. We have some new people that might be here today, and I can't wait to hear about what Rick is working on. And Skip, it was great to meet you earlier. And I think Nush will be showing us some of his work with the NIH 3D print exchange.
Yeah, that's exciting. Okay, I'm going off camera, but I'll be here.
Excellent. So we just got a demo of the NIH's beta 3D print exchange that a Brandeis intern, Nush, who just finished up his MBA program, designed a metadata schema for. And hopefully he'll have time to show up, although he has just been in 2 hours of e-NABLE meetings. But we thought we could also share our schema and get some feedback. And basically, Nush interviewed a bunch of e-NABLE leadership and looked at all of the resources on the hub, on Thingiverse, on NIH's exchange, across the internet, and aggregated, like, what do we care about? We each think about different things when we think about an e-NABLE model. So there are different types of ways to sort them and categorize them and the information and details that matter. So we've tried to lay that out in a new schema for their site. And the hope is to not recreate content that's on the e-NABLE hub, but to aggregate it and link back out to it. So sort of had like a more publicly viewable, curated model list of our favorite models to work with from the community. So lowering the barrier for entry and then simplifying some of the amount of information. And Skip, I loved what you were saying earlier about the FIRST robotics model, both from communities that already know how to technically build and engineer things, and from a community involvement is required already perspective.
Yeah. By the way, folks who don't know me, I'm Skip Metz. I just moved to Georgia about a year ago from Rochester, New York, where I had spent 8 years with John Schul doing e-NABLE things, and have a chance to get to know some people in the Georgia area. So I met Brent earlier this morning, and we'll follow up with him on some things. But one opportunity is maybe to see where we could have some connections with FIRST Robotics. So Brent and I are interested in that. If anybody watching wants to talk to us about it, please feel free. So, you know, I'm going to follow up with him. He might join us later.
Are you in the Atlanta area, or which area?
Yes, I am. I'm north of Atlanta on Lake Lanier.
Do you know Decatur Makers?
Probably.
They were a makerspace right outside of Atlanta that I visited years ago, and it was amazing. There's like such a huge eclectic collection of materials and space design. It was really cool.
Yeah, I'm thinking, you know, in the coming year, I might get involved in some of those things.
Yeah. Very cool. And I know like Georgia Tech is such a power hub out there for engineering and education. Right. They have some amazing maker spaces.
Yeah, I used to belong to one in Rochester, New York.
Yeah. They're sort of spreading into all the communities now. Always something local. Next to Brandeis, where we are just outside of Waltham in Weston, there's the Weston Arts and Innovation Center, which we're viewing as a good place for e-NABLE. They have some community involvement there. They've made a few practice hands, and they can do stuff that we can't on our campus, like they have more parking for the public to just come by. They're part of the public library, and they're really just 10 minutes off our campus. They're very close by. So we've been hopeful that they would start their own e-NABLE chapter that could host some of our students as well. I don't know who else will make it to this meeting. We'll see who else joins. I think Brent was going to try to join. And Nush may try to join too. And I don't want to scoop Nush too much, but if it gets to be like halfway past, I'll share some of the metadata he's been working on. Rick, do you have any exciting builds in progress?
Oh my God, yes. We've got some crazy stuff going on, and we're kind of tickled about it. I'm just not really sure what I've already shown you. I've also been speaking to Ian Davis, the gentleman who built that amazing hand that you see all the time on YouTube, and he's working on some interesting stuff he sent me. I was hoping maybe he'd come back and talk to everybody.
Brent and Rick, I think that you would also be a good pair to meet each other. Rick runs the New Member Meetup, but also does a ton of crazy innovation on e-NABLE platforms and materials and modifying what's possible and fitting them to individuals. And Brent, I just met this morning at a meetup about a really exciting K-12 initiative. I know Brent coaches First Robotics and has built some STEM programs at a couple high schools and has some amazing international e-NABLE production along like shipping things and stockpiling different models and trying to get them into people's hands as useful objects for individuals, as training objects to inspire other makers. It sounds like there's a rich space to explore. Glad to have you here, Brent.
Thank you for inviting me.
There may be a few more people showing up, but we'll see.
Just FYI, I have a class here. They're gonna be working independently, but I may pop off and on real quickly to give them instruction and whatnot. So
cool. What's their topic?
They're robotics. So they're actually, can we all grab a Sphero? They're learning JavaScript with Spheros. And so right now they're learning sequencing, selection, and iteration. So they're just starting, but the course is technically robotics. So eventually we have, I don't know if you've seen the Unitree Go 1 robotic dog.
Yeah.
It's like a mini, what are they called? A mini Spot. We have one. And so they're gonna eventually start doing some AI and ML stuff with that.
Very cool.
So pretty excited about that. I'm gonna get them started and I'll be right back.
Yeah, absolutely. Oh yeah, the Unitree Go 1, it looks just like Spot. It's got the same leg articulation. I'll put a link into the chat. Rick, this bionic stuff sounds fascinating.
Which one?
The link you just sent with the bionics collection.
Well, what that is it's a landing page I sent you. I'm just putting it up now.
Yep.
And it's in the e-NABLE. It's basically this is basically a sandbox I'm putting up. It's pretty new, but I thought you'd want to take a look, and it's real easy for me to update and put things into.
Yep.
And if you have any interest, you're welcome to play.
Very cool. This is exactly the type of thing that we'd like to link to from NIH and highlight, bring it to people's attention so they can find it.
Yeah, that's you've got me there. It's like sometimes you just can't find what you're looking for. So I had talked to Jeremy about putting up a little landing page, just a place where we could, just put some things of interest in. There's so much good information out there if you can find it.
Absolutely. It's a rich community and there's so many hearts and minds working on this stuff.
Yeah. So I was going to put it up just to just as a sideline, or not to add one more level of complexity, but just kind of for people that are a little lost.
Oh, and I think seeing what you're doing, even like some of the platforms that you find useful, like you're really at the edge of the best, newest stuff. That one with the bike chains is absolutely crazy.
We had a meeting about that at the last Bionics meeting. I'm sorry you couldn't make it because it really turned out good. It ended up 2 hours. that I
Wow.
stayed on with France. And they really want to do the bicycle chain on their hand.
Yeah.
And we basically got into some very good discussion on bionics and why would you use a servo versus a stepper versus a actuator. It was an
Totally.
excellent discussion, and we shared some web pages and things that I thought did a nice explanation.
Was that streamed? Can I go look that up?
Yes, it was on the last Bionics meeting, but we only recorded the first hour.
Yeah.
We ran out of, but we reconvened and did another hour.
Cool.
And it ended up quite good. We had one of my Bionics that I have back here on the shelf that we demoed. And I really don't know if I've shown you that one or not.
I don't know. Can you show it to us?
Sari. Oh wait. Yeah, let me grab it real quick.
Cool.
Hold on, let me go grab it. I'll
What is it? What is it?
I got no pants. I just need this hand. Shut up, turd. Bella. Bella, stop it. Stop. What are you, crazy?
Skip, have you found a new First Robotics group to work with in Georgia?
No, I haven't, and I've got a limited amount of time that I'm interested in investing. Although I'm retired, I'm close to family, grandchildren, and great-grandchildren
Oh, that's
for the
good.
first time in a long time. So they're keeping me pretty busy.
That's great. Oh, Rick, is that the Bionics you were talking about?
Yeah, I was just plugging the battery pack in.
That's cool.
I have this battery pack. I'm just going to plug into it real quick. And the reason we brought it to the last Bionics meeting was that they were looking for some examples. I was asked to put some servo stuff together. And as you know, I normally don't do servos, but I said I would. And this one's actually quite slick. It has a thumb that rotates this way and also opens this way. And each finger articulates. Very quick. It's fairly fast.
And one servo per finger?
One servo per finger. I also showed one last week that has 15 servos.
Wow.
Which is totally crazy because from a power perspective, it makes no sense. The amperage, you know, it's up about 3 amps at that point. And that's the point I was trying to make with the French guys, is that, yeah, you can stack servos, but, you know, do you want to be a walking battery? But yeah, this one's kind of cool because it has RC helicopter parts on it. And what we're finding is these make it super easy to make joints, because not only are they super cheap, we're talking about $6 for a bag of them, but they're aluminum, very, very strong, and you can make them any length you want. They're basically for the helicopters. Actually, I think they use them in RC cars too, but for transmissions and such. And we also showed a transmission that we were using. It's like a transaxle that we bought for $6 on eBay, and it works very well as a Whipple tree. But yeah, this was kind of the thing we did last week, and found this little base on that was actually on the e-NABLE site, just to stick hands on so you can prop them up. But yeah, this was one of our little props we had last time. I normally don't use servos.
Yeah.
But it's okay. We did it. We use this thing to for writing actually programs that we're doing, because right now we're building a lot of Android programs so we can communicate with the hand remotely. And we're doing that with MIDI protocol.
Mhm.
And it makes an awful lot of sense. It just works. It's automatically sensing, touch, because velocity and touch are all built into the MIDI protocol. You don't have to do it.
Oh yeah, very cool.
So the MIDI protocol has been working out real well for us. Not to mention the fact that when you're all done playing, you can plug it into a MIDI or a synthesizer stack and have
And
a
listen
pretty
to
good
it.
time. Yeah.
That's cool. I know there's like
those
also
inexpensive parts that you can get that were made for other purposes are great, because I found that it's not good to put metal rubbing against plastic and vice versa. So if you can put joints that have metal
Yeah.
against metal, that'll
That's
last
one of the
forever.
things we like about these little things here. If you notice, they actually have a ball joint in it. So you can actually tighten it down as much as you want, and it won't jam, because there's actually a roller ball here on each side. So you can clamp down on it. Unlike when you're using plastic, it'll bind. These will not, because there's a roller in there. And I want to say
they won't
paid
wear
$6.
down.
No, and we paid about $6 for a whole bag of them.
Yeah, that's great.
And, yeah, and a lot of them use a standard, like a number 3, so you can actually extend push rods any length you want. But it made the build a lot stronger. I mean, you could even see from the palm, it made it a lot stronger, and a lot less. There was a lot less flex and wobble.
Yep.
We're all about off the shelf. We have no budget, so
Yeah. No, and the bike chain you showed too was another, like, look super strong, super cheap.
yeah. The bike chain, actually, you remember the springs on the top are gone now. We got rid of that, and we've removed the springs, and now that bike chain is just about awesome. It's you remember the tensile strength is 2,200 pounds.
Yeah.
So we're using guitar strings as the ligaments. And, we got into a discussion last week about ligaments are bad. Well, they're good enough for us. I mean, we're doing okay with them, and as is every other animal on the planet. And we're using guitar strings because they can take about a ton.
Yep.
For the linkages, and they're super cheap.
Yep.
So it's worked out real well with that finger. It would take me about 3 days to print fingers on my 3D printer. I can make it one of those bicycle chain fingers in about an hour.
That's crazy. So much faster.
And stronger, and built-in roller bearings, and it's
Do you
just
have
hard
one
to
that you
find
can
one.
show? I think Brent that'd be a cool thing to show
Sari,
him.
could you grab, let's see. Yes, I do. Let me grab it real quick.
Cool.
I think I ran it out there in the other room. Let me go grab that real quick.
What do you want?
Cool.
I think it's in
Brent, I think you'd like seeing this bike chain innovation. Dr. Rick is always working on the cutting edge of what's possible.
He was using, I apologize, he was using a bike chain for,
As a finger. So
Right.
like sort of like the chain itself can be tensioned, and then it can hold a
Okay.
huge amount of weight and is very low cost, very durable, and still can like actuate and sort of form around things nicely because of the chain linkages.
yeah, which I think kind of speaks to what we were talking about earlier today with end user, final product usage,
Yeah.
making something that's a little more robust, is very beneficial.
We actually mounted it on a hand, and it just performed beautifully. We've pretty much beat it to death trying to hurt it, trying to destroy it. We've given it salt, water, we've given it all kinds of things. We actually have this is one that we put together. The chains, and as you can see there, this one's had really been beat up, but as you can see, they articulate beautifully, and they almost have the same, actually almost better than a human finger.
Wow.
And
What
it's
are
really
those
about
bands
the
that are connecting?
configuration. Well, I'll go through it if you'd like, but as you can see, this one's really beat up, but you can see how well they move. The way they work, let me just bring one up. The way they work is it's all about the configuration. And we take certain ones of these and we solder them very quickly together so that some move, some don't. Like these don't move. these do. And then these springs have been eliminated. We don't need these anymore. This is the old version that we were really beating up, trying to destroy it to see just what it could take. But as you can see, these things will roll almost, my finger won't do that. It's really just about configuring it, and we use staples. You know, on the hand stapler, we use staples to bind them. And then it's really just a soldering gun. And in the end, you have something that moves incredibly naturally. And I can't find my little test one here that I had. I usually have a little test one, but in the end, it's creepy looking. It's really Terminator looking, but it can really grab like an octopus almost. And,
so we were having a discussion earlier about flexible molding processes for joints and those types of things. And that would almost be something where you could make a vacuum form mold, do a left and right side, and do a flexible epoxy and make it look kind of like a hand, you know, and just wrap it around it.
now that you mention it, that's exactly what we do with our partial. We take, hon, could you grab that hand up there? We take the individual's hand. We do one of two things. We either do LiDAR to scan the individual's hand, and then we make their hand. This one is actually mine, even has my fingerprints. And then what we do, let's just say we will cut the fingers off it or whatever to do a test. But when we have their hand, then we vacuum form it. We built a vacuum forming machine in the other room. It only cost us $70. And we're doing, it's a 12 by 12. So it could do a 12-inch squares. And then we vacuum form the residual hand, whatever that is. Okay. At that point, we mount these fingers on it, and you would be astonished at the strength that we're achieving out of that. We build them with both. We build them both bionic and non-bionic.
You said that you eliminated the springs from the design?
Yes.
So what's your tensioning device now?
We changed it, especially on the bionics, because one of the issues, as you know, with bionics is you put in an awful lot of infrastructure, be it programmatic or sensors, in order to stop the fingers, especially in bionic. Otherwise, it'll tear itself apart, right? You get really, say you have a relatively strong motor or motors, and whippletrees or not, if it's an individual fingers, and the motors will go until they damage themselves for the most part. So what we did is we created a loop. Okay, so each finger is on a loop around the motor. So the loop, we can change the tension of that loop. However, the tension is what determines how hard it will pinch. Now, when the motor runs, it of course will tension it this way. When it backs off the opposite way, it opens because it's on a loop. So it either goes one direction or the other. So that eliminates the need for the springs. What's really nice is that when it hits its individual, when that particular finger hits its individual limit as to how much the others can continue because it's a loop, and the springs then become unnecessary. And it actually just works amazingly well with no infrastructure, no sensors, no, programs to sense motor stress. All of that tends to go away, especially given that you can change the tension. And we tension them based on what the motor is capable of. And we've done this with actuators. We've done it with, we prefer brushless motors. It works beautifully. And we don't use, we're not using myos. We're using what we call index gyroscopics. And that allows us to operate the arm by setting up a series of gyroscopic movements. So like, say I want to do this, I would programmatically maybe twitch twice, and now it knows that when I move my hand now to the right, it's going to run those fingers and nothing else. So the index gyroscopics takes all the complexity and the circuitry away from the actual hand.
That's
So
impressive.
it really, it just works. And one of the things we did is we put it on a scuba diver, and we wrapped the motors in a sandwich bags, and then we sealed them with a bag sealer that we bought at Big Lots for, I think, $3. And it made it waterproof. And you can actually, this thing was being used to tear barnacles off a ship. That's why it's all
Wow.
beat up, but that's what we want to do. We want to beat it to death, really hurt it.
Yeah,
And
you
this
can't
is
do that with
after-
PLA.
No, and this thing can rip barnacles off of a ship. Not
Wow.
only that, it was picking up nail guns. We had to build an underwater nail gun for them. And this thing is just monstrously strong.
Rick, I encourage you to share those designs as much as you can with the community using Thingiverse or Umagine. And, you know, I know it takes a lot of time to do the documentation, especially when you're iterating so fast.
Yeah,
Boy, that
this thing
sounds
is
very
so
innovative and very new. So I can't wait to see your designs.
one of the problems we've had, Skip, is it's so new, we haven't had time to document it.
I understand. I've been there.
Now, what's really interesting, what we had talked about, even Ian Davis, I discussed it with him. And what we want to do, maybe what would make more sense is maybe to do a video. This is how you build one.
You bet.
Yeah, let's get
And-
that video up.
Yeah, and because anybody can do this that has soldering skills. Now, a lot of countries, you know, are going to have maybe problems finding a 3D printer, but who doesn't have a bicycle?
Yep.
Who doesn't have a soldering gun? I mean, you can go down to Ace
Solder
Hardware.
gun, staple gun, bicycle, and you got it.
And then you're there. Yeah, you're there. And I cannot, with my printer, make fingers anywhere near the speed I can with this.
That also makes me think, Nush is here and can talk a little bit about the 3D print exchange where we're trying to curate some devices. Maybe we need another section. We could have like the e-NABLE curated collection of like the most popular e-NABLE things, but we could also have the innovation section, and that could just link to this new landing page you're building, or have some of those, like some pictures and some YouTube videos of some of these edge pushing pursuits, mainly just so that like someone in India, in rural India with internet connection, could find it and watch that video. Because I think like finding even what's possible is really difficult.
Yes.
Yeah. One of the problems, you know, we're having right now is really just catching up with the physical. You know, so that's why we were thinking we're doing a video, but what we're trying to do is we're trying to retrofit this into every available e-NABLE hand. I mean, that's an awful lot of tech to go wasted. We want to be able to retrofit this onto, right now so far we've done the ARX, we've retrofitted it to, and we've retrofitted it to the Wahoo. And it worked beautifully. I mean, it just works. And what we're going to continue to do that, probably not with the bionics though. There's a lot of the hands that just don't run themselves.
They can't fit a motor.
However, one of the things we did talk about is we built one that actually had a pouch, like a belt pouch that everybody's already used to. And you run the tubing that you use in order to run your filament to the printer. And it's Teflon and it's
the PTFE tube.
We actually run that to the pouch, and the motors and everything are in the pouch. And that's really useful for hands that do not have a great deal of room inside, rather than hanging all of that on their wrist or as a gauntlet, which is crazy. This pouch scenario worked beautifully, and it was doing a very nice job of pulling the strings on individual fingers and whatever you wanted to do. Everybody's kind of used to the
configuration.
Yeah, everybody was kind of used to that anyway. Everybody's phone is so big that, you know, wearing a pouch anyway. And we're doing a lot of Android code. We're offloading a lot of the brains to the Android phone because it makes more sense. Why put the brains in the hand, increase the complexity when you can download an app.
Totally. Nush, I see you're here. Would you like to show your presentation briefly to the group? Talk about the work you've been doing with the NIH 3D print exchange stuff?
Yes. Can I have like 2 minutes to get everything set up?
Totally, totally.
All right. Thank you.
I think Brent and Rick and Skip and anybody who's watching the stream later would be cool to see. Nush has been an intern for us for the fall and is just wrapping up last couple weeks. And the NIH's 3D print exchange has been a 3D print clearinghouse originally for molecules, how Brandeis got involved, contributing some molecules back in the day, like 7-8 years ago. And then they became a clearinghouse for PPE during the pandemic, where they had a lot of the face shields and other pandemic 3D printed maker response stuff. And they sort of started being the clearinghouse because they had like approved for clinical use, which at the time meant a hospital was using it. I don't know if anybody else on the call we did a bunch of PPE stuff and we got more involved with them. And then they sort of became a nice place to put open source hardware for lab use. So for research lab spaces, for classroom spaces. And they have a prosthesis section that Jeremy on the call put a lot of the original content in, but hasn't been updated in a long time. And NIH is just about to launch a new 3D print exchange that we just got a preview of this morning. And it has really cool stuff, like it does file conversions, it does mesh repair in the website. You can now, like, more than Thingiverse, you can actually rotate a model in the viewer before you download it. And so Nush has had a couple of months to conceive of, interview folks, and think about what type of metadata we want to associate with the e-NABLE hands. That also for the NIH is helping them think about for other open source hardware devices, how we categorize them, how we search and sort, what type of information is useful for folks. And so Nush has a presentation that we just gave to that team as they build out their website. And what I'd really love to pick the brains of everybody here on is there other metadata? Is there other information that we want to associate with these devices? And this is not like a one and done, like hand it off. They're developing the site. We can eventually we'll have to fill the site. We'll have to pick which models go on there. I think Jeremy and I will start curating a lot of the e-NABLE stuff. And the goal is not to put all 100, 200, 500 e-NABLE derivative devices up, but to curate like the best 12 and not to recreate all the content, but to link out everything from a central repository. Just a second to see if I can. Oh, I can't give you, Jeremy, if you're still hearing us, Nush would like the ability to share a screen if we could make him a co-host.
Absolutely. Hang on a second. Should be okay now, Nish.
So Brent, this could also be a thing that we could give you a collection. Dr. Rick, you could have a collection. We could name them different things and help people sort and surface the things that real like makers who are deeper in this spend more time on. We could surface those to the top and then link out to all the resources that already exist. So Nush, you want to introduce and take it away? Oh, you're muted still.
All right. Can everybody hear me?
Yes.
All right. Good. All right. So basically, this is just like the introduction of e-NABLE, what e-NABLE does, chapters around the world and so forth, and kind of like the mission statement per se. So over the course of my presentation, I was given 3 tags. I'm sorry to Jeremy and other folks who are in the previous presentation. I'm physically going to go over, summarize most of the same thing that I just explained. But one of the thing was, and Ian mentioned that a couple of times, was the metadata schema, the organization process flow, and the family tree per se. And in a sense, to kind of like, make it much more easier and for folks to find, locate, and access, and allowing all the data to be in one place, in a sense. So over the course of the internship and so forth, I interview some folks. I usually ask them a few questions, and sometimes we have conversations that were, somewhat different from these questions that are posted here, and basically just kind of like get like a deeper understanding of e-NABLE as a whole, and kind of like finding ways to create better process flow. or to kind of like organize data better in a sense. So in terms of like the process flow per se, you know, reconfiguring the landing page and making it easier for folks to kind of like navigate the different processes and steps that, you know, that will help them to get to the information or to the resources that they might need, making it much easier. As you go through this process, so from the directory to if you need a hand to build a hand and so forth, if you come right here to child and adults in terms of classification, as Ian mentioned, and I think that's a great idea, you know, implementing or integrating the e-NABLE recommended devices and the devices that, you know, are still being tried and run by makers and so forth will somewhat be implemented somewhere here in terms of type of device and so forth. And then you come down here where it gives you like the whole device catalog in a sense. This right here, this is kind of like just like a screenshot, a couple of screenshots of like all those metadata for a particular device. This is just one device, and this goes down a couple of pages, but this is just like a 3-page screenshot, and it just gives you kind of like the meats and bones of everything from like the country that it was made to the makers, the ID, to, you know, the 3D file, to the source file, to the license, who licensed the product, to, you know, the cost, you know, to how strong it is, how popular it is, you know, how many folks have downloaded the file, how many folks have, you know, viewed the file and so forth. It gives you all and every information that you might need to have on like a particular device. And it also, at the bottom, it will tell you if this is among that top rated, recommended, highly recommended device from e-NABLE, or if it's not among that top rated, highly recommended device. In terms of like the organization, going back on my previous statement, there was kind of like two big issues in terms of finding the right devices and matchmaking in sense of like adding in terms of like matching folks with the right resources and the right information that they need. So in terms for one, finding the right devices in terms of like the device catalog, this right here, we were hoping for, as you can see right here, this is the kind of like the breakdown from if you need a hand to how to build a hand, to like the resources that you might need, to, you know, volunteers and the e-NABLE Hub and so forth. One of the things that if you have gone through the e-NABLE Hub and the e-NABLE website, you will notice that most of these are from different websites and so forth. And one of the things that we've been talking about was kind of like integrating it into like one and making it easier for folks to navigate and move from one point to the other instead of, you know, going to, let's say, e-NABLE in the future or the hub or so forth like that. Just kind of like a one-stop shop for creating hands or creating device as a whole in 3D printing. That same idea in terms of matchmaking, using that same analogy of one-stop shop, of allowing you to reach out or connecting you to folks who have the expertise or connecting you with the resources that you might need if you are lacking those resources or if you are lacking those expertise. This, in a sense, like that will kind of like enable you to do that, and, you know, using this pool, you know, resources all around the world, whether it's in India or it's in North America or South America or Europe in a sense. And in terms of creating like a hand, one of the things that we've been talking about was kind of like making it very easier and simplifying the steps, taking out all those like redundant steps and just creating like a 1, 2, 3 step to create a hand. Like one, you need this, you need to do this. Whether you need to register first, you need to have your print assembled second, and you need to, after you print it, you need to validate it. Just making it easy and simple for folks to use. And this folks everywhere around the world make it easier in the sense for you to use. And these are kind of like the resources when you jump down and so forth. And when you do have your device, whether it's like a wrist power or elbow power or finger power and so forth, based on that categorization that I mentioned, these are kind of like the recommendations. And when you click on those recommendations, we give you that whole data schema and so forth and things. And this is just kind of like the breakdown. Also, again, that you can find on different type of e-NABLE website, but we're hoping to kind of like integrate everything into one and make it easier for folks to go from there.
I think we have time. You want to show us the metadata briefly? I think you could walk through some of it.
Yeah. Yes. Okay. All right. Let me know. All right. All right, great. Okay, so this.
Before we jump in the metadata, can I just make a couple quick points that just kind of came to mind while you were presenting?
Yeah.
So two things, and this kind of also goes back to Dr. Rick's design. We might want to think longitudinally about volunteer types, right? We were having a conversation about like what specific skill sets different volunteers might have, and technical documentation might be a type of volunteer where, they don't necessarily have the means to print or make some of the parts for prosthetics, but if they want to volunteer to help write up the documentation, help enter the metadata that we're discussing, help make videos, those kind of things, then that might be a good project that both high school and collegiate students could do and be involved in, and you could get some fairly professional quality information from that. But that was just a thought. And then the other one, looking through the site, it might be worth looking at clarifying volunteers versus recipients, because the way the site's structured currently, it's kind of murky as to where you're going in terms of direction from that. And so if you have essentially, an A/B split that's occurring where if I click on, I want to be a client, then I'm going there and all that information is related to me, versus if I want to volunteer, I click on that and it's taking me to a completely separate component.
I got that in notes. That's awesome, Brent. Thank you.
Yep.
So this is just kind of like the walkthrough of some of the data here in the schema. The identifiers, the model name, the device model, the views, the downloads, the make, keywords in terms of search, allowing you to, find the device, actuation, point of attachment on, every device and so forth, affiliated organization, the country of origin, where the device originated from, the last date it was modified in designer names, license, organization, the model the device was derived from, and kind of like going back to that family tree. Suggest and I think Ian already mentioned this in terms of the suggested fabrication and methodology, or suggested material that you might need in terms of building a specific device. Details and so forth. And it, as you go down, you talk about the assembly material. There are videos, tutorial videos on how to, when you do make the design, the device to put it together. Obviously, the 3D file itself, the source CAD file, the device maturity, from grip strength to how difficult it is to cost of material to popularity and so forth. And the link right here taking you to the official e-NABLE website. And so this is just one sample. And yeah, this is a catalog right now. Every existing devices that's on e-NABLE site, and this it goes for 141 page. And as more device is introduced, we'll basically implement it here into this catalog. Yeah, that's pretty much. Sorry, that's pretty much it.
Good job.
Thank you, Nush. It's been great to see your
Thank you.
progress on this huge complexity of design and trying to simplify and aggregate and find patterns. And hopefully in the next couple of months, this will be up on the web with the top ones at the top and then links out to everything else. So people can dive into complexity if they want, but it's more challenge by choice. They can also just get started. So I've shared that metadata schema that we've been working on into the chat. That's sort of the top level deliverable that will build out the container. But eventually we're going to need a lot of help from the community about data entry, moving things over, and it has to be a living thing. So I think Jeremy and I are going to start as admins. Nush is headed out, graduating into the real world, and we'll be looking for more interns to help us with this going on. And we view like the metadata, the content, as new designs develop, it's all a living process. And Dr. Rick, we got to have you have a section on there that's like the crazy sci-fi future section. Or materials beyond traditional digital fabrication, like pushing the envelope with both durability, but complexity, and also like simplifying like how long it takes and which materials are possible.
Lunatic fringe section, maybe.
Lunatic fringe would be great. I think we can name it whatever they want until we get an email a couple months later. Someone notices. But it would also be cool, like Brent, from your perspective, if there are certain ones that work well in K through 12 from like pedagogy standpoint, like these are teachable models versus like maybe that's not the same ones that are great at removing a barnacle from a ship hull. Or maybe it is.
I actually really liked that idea. I popped out and talked to Jacqueline about it really quick because she's got class as well. I like the idea of tying in the concept of everyday products that can be used in different varieties of ways. That's really kind of an open-ended design project. And so I think that that's something that's very valuable. We were also just discussing the value of technical writing for high schoolers, because I think that we could say in our English class, take the unlimited V2 or wherever it is, pick a model and rewrite the technical documentation for that, produce a video of assembly, and then you're using that as a class assignment, but you can a little bit better on getting more robust information. Jacqueline's right here, by the way. She's got.
I love that. That's hi, Jacqueline.
But you could even take that a step further than that and do it in the form of how it would look at a company. So like, here's our engineering team, here's our manufacturing team. I need you to write work instructions for this team to then go build this. You know what I'm saying?
Totally. And I think that also fits into the first robotics thing that Skip was talking about, how it's like a bigger team with more roles.
Yes, absolutely.
All the jobs have to be done, so organizing it sounds good.
I'm sorry to keep jumping back to this, but Dr. Rick, do you mind showing Jacqueline really quickly the chain hand? It's just so cool.
It's so cool.
I honestly, I don't have the model I usually show you, so all I've got is this beat up thing. Unfortunately, it doesn't move as well as it used to because this thing's really had some beatings. But yeah, it's basically this is,
my gosh.
Yeah, and the motion is so realistic for the most part. This is let me see here. Here we go.
Realistic.
Yes. And that's been like one of the big complaints of clients is that it doesn't have the grips, the standard, prints don't have the grip strength to really.
Yeah, you hit it on the head. a lot of people have complained, and the finger is always the first thing to break, of course. And the basically just, I know I'm repeating myself, but the tensile strength on this is about 2,200 pounds. And it's strong enough that it concerned us that we're building breakaways. So if, you know, it gets stuck on something, it'll break away, and we get to choose the poundage for that. But as you can see, this thing, my fingers would never be able to do this.
No.
And you can build one of these in about an hour with a soldering iron.
Rick, I encourage you to think about, and have your colleagues to think about, a cosmetic glove to go on that too.
Well, we talked to John Shull about that, because he had a, apparently he has access to someone in India, I believe he said, that has
I
a
was
glove
there.
that has a glove that,
I found it very difficult to put the glove on the prosthetic. And so somebody play with that and find an easy way to make the glove go on.
Just remember, that's because the fingers are so big. These fingers are incredibly small.
There you go. So that might be the answer.
Yeah, I mean, we've stuck it in a couple of different things. We
All
put
right.
it in a,
Or if you find gloves of the right material, you might be able to do sort of like a heat shrink onto
Oh,
them.
that's clever. I
Put them
like
on
that.
loose and then, you know, heat shrink them.
there's a lot of ways, I think. I've been trying to watch YouTube videos on how to make you know, fake fingers and latex, you know, I haven't done very well with it. We've got a couple boxes of the latex out there we want to play with. But they make it look very easy on the videos. Mine didn't look so good. But you know, funny enough, the kids actually like the Terminator look. So I don't know.
Got to give it to a geologist, and they can do some lava sampling with it.
There you go. I think that, you know, we've had a lot of speakers on here, especially some of the ones that have come from companies that are building very expensive builds, very expensive designs that are out of reach from a lot of people. And I haven't heard one of them not complain about the finger technologies. That's been their Achilles heel, they break.
Yep.
We have so far not been able to break this. And we've done horrible, horrible things to that hand I just showed you. I mean, I'm surprised it isn't all.
You were saying like salt water too. That's usually the greatest enemy.
Well, we did that on purpose because one of the things we weren't sure of, it came down to how good of a bicycle chain you purchased. We found out that these, we didn't know there was that many. These actually have their racing chains, and they have a bunch of already cut slots, and where the pins go is it goes straight through, which is not true for some of the cheaper ones. And they have real roller bearings in them. So what we were able to do is spend a little more. I think we splurged and got like 30 feet of this stuff for $17, which would make a lot of fingers. And I just don't know how much cheaper we could make it now that we don't need the springs anymore. The springs were a problem.
Yeah,
but that's gone. And then we got
That's great. Can't wait.
little robot guy here. He's kind of fun.
Oh yeah.
He cruises around and tortures the dogs, and then he's got he runs on a microbit.
Yeah. Looks sort of like an M-bot.
Yeah, a little bit. Yeah, he's kind of fun. He's just fun to test code with, because we were working on a stick for the blind.
Yeah,
and we were getting away from the sonics and going to the laser driven. And we, you know, it actually is not as difficult as one might think.
We had a hackathon here once where we gave 12 teams M-bot kits, and we said, hack the M-bot to solve a disability. One of my favorites was Roombas, a swarm of them to clear sidewalks of snowfall, like little outdoor Roombas. And one was an e-cane, where they turn the whole robot into a stick.
Yeah. I mean, you know, a lot of the times it's just taking stuff you already have existing and just repurposing, especially when you don't have a budget. We're still leaning very heavily on the microbit processors.
Yeah. So I always love seeing the sci-fi stuff you're working on. We're coming up to the top of the hour. So if anyone has any final thoughts, otherwise we'll be back in a month. And hopefully we'll have everybody here again and have another great conversation, maybe get some newcomers. Rick, if you're up to it, still having new member and education, I think works well until we're at too big of a scale.
I'm good. I think this is awesome. And I think that, you know, the new member people would probably really appreciate this more than just introducing themselves. I think this is kind of nice. They get to see, you know, real world, what is everybody doing? And like what Nush is working on. You know, my hat's off to you, sir. I don't know how you managed to do all of that, but
well, and it's also that the only e-NABLE is not just making devices, right? Like Brent was saying, with all the educational use cases, it's documentation, it's communication, it's sorting through complexity. And it's also sort of a good template for all of the other open source hardware that people are just starting to wrap their minds around that I think will be huge for education in the future.
I think, yeah, I agree. And we're really hoping to see some new innovations that we can bring in that everybody can benefit from.
No, and I love that the accessibility of materials is a big piece, lowering the barrier from you don't even need a machine. You just need design and documentation.
Yeah. I don't know, Ian, did you ever look into that, the thermal farming machine we sent you the info on?
We have just a little thermoformer,
Okay.
but I'd love to see your designs for the one
No,
that you
we
built.
bought it on eBay.
Oh, no,
actually.
I did see that one. I did see the
Yes.
eBay one. Yeah.
Big $70
Yeah.
$70 purchase for a 12 by 12.
So cool. Well, maybe we can, next topic, we'll start next meeting. We can talk a little more about thermoforming. I think there's a lot there. Good discussion topic. I'll make a
I
note.
would think Jeremy would be able to fill us in a lot more on that too.
Well, no, I imagine you've got as much experience as I do with the vacuum forming. I have been doing a lot of work lately with pressure forming. I have a new desktop pressure forming machine here, but that's not going to be, you know, it's not as accessible price-wise for the general public. But yeah, I mean, as far as exploring technologies, I'd love to have that discussion.
Awesome. Well, great to talk to everyone. Want to be sensitive about the time, but we're always on the hub, and we'll see you for another meeting in a month.
Thanks all.